Okay, example number 2. Without the use of a calculator, determine if the following values are positive, negative, or 0. So A through J, I'd be very surprised if I worked through all of these. Never know. A through J, it's really important to locate where the angle is in standard position. If I take my XY plane or my Cartesian plane and I measure from standard position, this is my initial arm. If I travel 90 degrees, I'm at the top, or I'm along the positive y-axis. If I travel 180 degrees, I'm along the negative x-axis. 270 brings me down here at the negative y-axis. And if I make one full complete revolution of a circle, I'm at 360. This circle, or this diagram, is implied whenever you're trying to locate an angle. Now, again, angles can be positive or negative, but for now, we're only trying to locate those that are positive. So without the use of a calculator, determine if the following values are positive or negative or neither. So it's nice to recall that the sine is equal to y divided by my radius vector r. Cosine theta is equal to my x divided by my radius vector r, and tangent theta is going to be equal to my y coordinate divided by my x. But for each of these, if I'm just simply trying to determine whether sine, cosine, and tangent are positive or negative, really all I have to think of is the y for sine. For cosine is the x. Tangent, I think about slope. So let's look at sine 30. So I make my Cartesian plane. 30 degrees looks something like that. My y values in quadrant number 1 are positive. Therefore, sine theta, or sine of 30 degrees, has to be positive. Sine is y. Y is positive in quadrant number 1. Move on. Cosine of 200 degrees. Well, 200 degrees is really important to identify where 200 degrees is. 200 degrees is in quadrant number 3. So I'm just going to put a little green dot, perhaps, I like green, right there. That is an arbitrary point in quadrant number 3. And we know that all the x values in quadrant number 3 are negative. So therefore, cosine theta also has to be negative. Tangent. Tangent of 130. There's my initial arm. 130 is about right there. I'm going to take a guess. Almost halfway between 90 and 180. So I'm going to ask, well, tangent, to determine if whether or not it's positive or negative, is the slope of that terminal arm positive or negative? Well, it's negative. So therefore, tangent of 130 also has to be negative. All right, sine of 250. The hardest thing about this is locating where 250 is. So 250 is actually in quadrant number 3. It is 20 degrees away from 270. Regardless, there's an arbitrary point xy, and what we can see is that the y coordinate is negative in quadrant number 3. So therefore, sine of 250 is also negative. Cosine of 300, 300 is in quadrant number 4. What I notice is that in quadrant number 4, the x values are positive. So therefore, I can conclude that cosine of 300 degrees, well, since it's in quadrant number 4, will also be positive. 150, where's 150? Well, 150 is right there, about 30 degrees away from the horizontal, short of the horizontal anyways. Cosine is right here. The x values are negative over here. So therefore, the cosine of 150 degrees also has to be negative. And I can keep on and on. But probably most important really, if you're trying to determine whether sine or cosine or tangent are positive, for sine, determine if y is positive or negative. Cosine is determined by the x-coordinate. Tangent is determined by the slope of the terminal arm.